what the quantum industry really needs to do is learn how to articulate what is the return on investment. And there's always a jump. You're never sitting there with all of the information in front of you. At some point, you have to do it.
Welcome back. Today, I am actually stuck in between flights, escaping hotel corridors. But in this episode, we are diving into the world of quantum, a technology that most of us still think kind of lives in science fiction novels. So you'll see us heading to London to meet the founder who's seen this all from the inside. Richard Murray is a physicist who helped shape the UK's quantum effort at a national level, but then went from steering this emerging field to being a front runner, building in it, leaving academia and his government work for a founder's life. Now, why does this matter? Because the world around us is changing fast with AI, with more data, more demand on processing power. So computation is rapidly becoming a form of infrastructure. And the deep tech founders who matter in this decade are going to be the ones who take frontier science and translate it into something that people can actually rely on sooner rather than later. So I asked Richard plainly, what is he building at ORCA Computing? And what does it take to turn quantum from future tense into a tool we can use today?
So ORCA is a company that builds quantum computers. We actually take quantum mechanics and we turn it into real computing hardware. We build these amazing quantum computers out of light, which can have the potential to change the way we process data. We think that quantum computers can be added to things like machine learning and very, very hard computational problems to make them better. Computing being quite energy intensive, quite bad at certain tasks, and quantum computing is really, really exciting because it's a way to sort of almost reinvent computing to make all those things better.
Notice that Richard doesn't start with mystery, but rather with a constraint, a hair-on-fire problem that needs urgent solving. That comes from a very real founder instinct. Clocking the pain point that computing is getting more expensive in all the ways that matter. Time, scale, energy. Now, if like me, you're not a physicist, here's a simpler framing. ORCA isn't trying to replace the computers we already rely on. They're building a specialized system that can help with the small but growing number of specific calculations that are otherwise brutally expensive in the current paradigm, almost impractical. And that matters because quantum has lived for years between two unhelpful narratives. Either it's always a decade away, or it's a science experiment, conducted in R&D workshops at close to absolute zero temperatures, something that your average business can't imagine using. So I asked Richard why he bet on light, and what computing with photons actually looks like when you're building something that's designed to ship.
ORCA works on a very particular type of quantum computers that use light, so use photonics. Certain people have got a fairly good idea about what quantum computers can do when they get really big and they can perform things like error correction. There are massive companies pursuing it, Google, IBM, very well-funded US companies, sort of very rigorously defined scientific philosophy on things. The other extreme would be you can decide to just listen to what your customers want and really implant quantum to see what can be done today. So we sort of talk about this thing called co-design between the hardware and what's realistic and possible and what the application would demand. And we're really at that sort of coalface, sort of intersection point between applications, future machine learning, and also amazing advanced hardware. Computers, historically, they've been built from electronics, so electrons flowing around. The problem with electronics is they can be quite slow, they also generate a lot of heat, and in principle, the idea of doing more compute with light, which is much faster, much less heat generated, is like a concept that people have thought about for a long, long time. Well, how on earth can you actually process information using light? So you start by passing information into a big network. That light is routed around, it's switched around a lot. It is in the process of switching that you're able to actually perform some sort of computational logic. The direction that the light is taking through this network is something that we use to encode information. You're then measuring the output of the light, and you convert the light then back into an electronic signal. And this is very, very unique to how ORCA does things. We also build in a component technology that uses gas, uses matter, which is rubidium gas, to actually create an ability for one photon to affect the properties of another photon. And that is actually more of a direct analog to a transistor. Ultimately, the thought of when is actually the whole of computing going to flip over to use photonics rather than electronics, I mean, that is a 100-year transition, but now it's becoming more and more relevant. So AI workloads are including more photonic interconnects because these things are bigger, more connected, there's more data flowing around. You're not just riding a quantum wave, you're also riding a wave of photonics being more and more central to computing architecture. And I still get totally excited about what we're really doing at a physics level, and just imagining that we could, as a company, be somewhat a contributor to that flip. Isn't it just amazing that now we have the capabilities as humans to just enact quantum mechanics, literally sit down at a computer and dial them up. I want a superposition of this, and there you go.
There's a rare combination of characteristics in what he just said. Awe for physics and an insistence on usefulness. Now, this mix is usually the difference between someone who can explain a breakthrough and someone who can carry it into the world. In frontier tech, that inner wiring really matters, because the work doesn't always reward you quickly. It usually takes time and grit and a hell of a lot of determination. So I asked Richard where all of this comes from. Before any of the company, when did science stop becoming a subject and become the way in which he navigates the world?
My parents are both science teachers, so from as old as I can remember, I just love science. I love science fiction, I suppose that's where it started. Big Star Trek fan. My mum used to give me her classes, chemistry papers, and being a sort of geeky kid, I used to take great enjoyment in just doing these exams on the kitchen table. But in that time, I read this amazing book. It's called Mr. Tompkins in paperback. It basically describes the world of quantum mechanics and relativity as if the speed of light was 30 miles an hour, and this just blew my mind. And at that moment, I decided to change my course to go and do physics. I just knew I had to know more about this stuff. I always think sort of creativity and imagination are quite important for scientists. Like, you have to imagine this stuff. For me, one of the cool things about Star Trek is just doesn't talk about the science side, but it also describes, a future culture, a future world, people interacting with each other. It's weirdly not all about the technology. It's the intersection between technology and people, without understanding what motivates people, what people like and what they don't like. Technology doesn't matter. And so I think I've sort of always tracked that love of science, but sort of curiosity and creativity to lead me to then do the physics degree, do the physics PhD, and then obviously spend the rest of my life pursuing physics. Starting ORCA, it was technology and people coming together, and that I think is innovation in a nutshell. If you wanted an easy life, you would not study physics, you wouldn't do a PhD in physics. What defines my family is we've always worked really, really hard. My parents would work incessant hours to make their students do as well as they can. I think as children we were brought up in a very supportive environment, but it was always clear that as a family, we work hard. Obviously, you can't stay up all night with however many energy drinks and brute force a quantum computer. And that's good, because if you could, then people like Google or IBM, with their multiple times more resources than us, they win. But you have to have a drive that's sort of, you might even say, unhuman. It takes a lot of deep thinking and creativity and application, thinking smart. I don't know if that sounds old-fashioned, but I do really believe in working hard and applying yourself to your full potential.
What he's describing here is a founder's operating system. Imagination paired with discipline and an obsession with human adoption. That feels like the deep tech bottleneck that we're living out today. There's not a shortage of brilliance. There's incredible science happening all over the world. Where we are falling short is translation. the messy work of turning research into something usable and scalable. And that feels like such an opportunity for impact and for doing really meaningful work. So I asked Richard what he learned when he was inside the national quantum effort at Innovate UK, and what he determined to do differently when he built ORCA.
I actually applied to be an emerging technologies lead. On my first day, the person I was reporting to said, "I'm glad you're here. There's £270 million of taxpayers' money to be spent on quantum, and there's no one else in the organisation that knows about quantum apart from you. So congratulations, by de facto, you're our quantum guy." I always describe working in government a bit like lots of other companies. You're a small cog in a very big machine. You're doing some really important work, writing policies that relate to the whole country, but you lose that direct connection. You realise the complete mismatch in speed. Startups pivot on timescales of months, and government thinks on timescales of decades. You have to build being agile enough to accommodate the fact that, if, for example, in quantum computing, everything is racing ahead at breakneck speed. New applications are emerging every day. If government are, for example, running consultations every 5 years or 6 months after that consultation will be out of date. What the time in government showed me is that I just always had this desire to start something, start a company, build technologies that can actually be implemented with customers. I don't think I really knew what it meant, but quite honestly, then the next step for me was just going and talking to lots of amazing academics like Josh and like Ian, but getting excited enough that they trusted me to, start the company together.
There's a moment when insight stops being interesting and starts becoming uncomfortable, because you can't unsee what you've realized is missing. A lot of smart people stay in that meta layer of strategy and roadmaps and frameworks. A lot of great science happens in exactly that space, and the work matters. But progress accelerates when someone decides to own the outcome personally. So I asked Richard what finally pushed him out of the institution and into the arena. What made him choose the risk of building?
Well, I've got so many friends who have always talked about starting a company, and quite honestly, I know a lot of those people just will never do that. And they'll never do that because they just won't ever be ready to just take the jump. And there's always a jump. You've always got a nice career, a nice job, 9 to 5, stable salary. There's always a reason not to start a company. You're never sitting there with all of the information in front of you. And I think at the end of the day, there has to be something that pushes you over the edge to go, I'm just gonna not do that anymore. I'm gonna risk it all, and I'm just gonna quit my job, and this is what I'm gonna do now. I think that moment's really important, because I think it's often described, starting a company, like it's a really logical thing. You've got to build a business case, talk to 20 customers, understand the market. That's all fine and all important. But the other side of it is just within yourself getting to the point where you know this is what you're going to do, and then not just knowing it, but actually doing it. And it actually doesn't take a lot other than just your desire as a founder to take the risk, commit yourself to picking one thing and just saying, okay, that thing is now going to be a company.
What Richard's naming here is the part that people don't put in pitch decks, that inner decision, the moment where you embrace agency, not because it's rational, but because staying put starts to feel irrational. And from all the conversations I've been having, that's where a lot of scientists end up stalling. They're trained to wait for the idea to be perfect or complete. But complete is a research standard. The world, on the other hand, adopts things that are useful, complete or not. And usefulness is discovered under constraints. So I asked Richard, what myth about spinning out he wishes researchers would drop? How would he recommend getting past imposter syndrome? And how do you know when to start building a company, not just running another experiment?
Whatever your makeup is, whoever you are, I think there is a way of learning how to be a startup founder or even a a CEO. You get introvert founders as much as you get extrovert founders. I actually think of myself as actually quite introverted, even though I spend most of my job being extrovert. What that means is I have to find a quiet corner to go and be introvert at the end of every day. But I will say all the time that I've never been a CEO before. So if anyone's sitting there wondering how to become like this thing, it's just about constant self-learning, constant self-evaluation. And I read a lot and I asked people a lot about how to be a CEO. I asked other CEOs. Just imagine you're working in a lab, your probably instinct is to carry on working on that thing. What I'm suggesting is spend a bit of time out in the fresh air, start talking to people, start pitching. There's nothing to be scared of. You formalize the idea of the company as you're pitching, but without getting out there, you just get caught in the trap of doing more research, never doing it. You don't know if you've got all the information that you need, but you'll probably never know. So get ready for the moment where you just say, okay, I know enough. I'm just going to do this. You might not have any money, you might not have any people, but you might have an idea. Launching into the unknown, as terrifying but as sort of exciting as that might be.
I see that as such a great lesson in action and confidence, to stop perfecting in private and start learning in public. Because until you put something out in front of the world, you're kind of just guessing, and you're not forced to move. In deep tech, momentum is so important, and it's often earned the hard way by picking a first deliverable that forces focus, forces trade-offs, and creates opportunities for feedback loops that can compound your speed. I asked Richard how ORCA chose what to build first, who they had the courage to say, here's our first product, and what sign told them they'd crossed the line from research project into a company.
I still remember the discussion that we had in a room that was much smaller than the size of this room, and there was myself, Josh, and Jamie 1 month into the company. They were having this great sort of technical brainstorming meeting, talking about some cool technology that they built. I was very much pushing for our first step into doing something that's useful, not going to consume a whole lot of resources. I very, very quickly realized that what they were talking about was something very, very powerful, for the simple reason that it was very simple. It was like, guys, we're doing this. Let's prototype one. Let's talk to a customer in a way that we probably weren't ready to have at the time, but we were just sort of like, we can build one as a product. Would you like it? The first customer said yes. So we actually then went on to sell one of these systems to the UK Ministry of Defence, their first quantum computer that they bought. All that end-to-end, first idea, first product, first demonstration, and then first delivery to a customer in the space of about 6 months. Founders are very often late to look at the markets and the outcomes and the commercial side of things. They are late to start imagining what the product would look like and launching the product, like really go all out to deliver your first product. Get as quickly as possible into the cycle of launching products, talking to customers, redefining your products, relaunching to new customers. And that cycle is truly virtuous, especially for deep tech companies. It's so easy to get stuck in my prototype needs to be a little bit better, or there's a little bit more science I need to do. Very, very few customers want to know about the inner details of the fidelity and the superposition and the quantum state. They don't want to hear about all of the science that you're doing. What they want to hear about is the impact that it could or will have to them as a company. So internally, we built a really, really exciting science roadmap, but externally, we communicate products and usefulness and relevance, getting things to market, building tangible things that demonstrate what you're about as quickly as possible. It was funny, I went to a conference where I stood up in front of the whole community and I said, what the quantum industry really needs to do is learn how to articulate what is the return on investment. And that one statement, I think, completely divided the room. The quantum has been rooted in the scientific discussion for a long time because it matters. You still need to learn how to communicate that science into a language that makes sense for customers. They want to understand about the relevance of the science. They want to understand about the application and the value that that science can bring.
What Richard's pointing to here is a founder responsibility that we've seen a lot of technical builders underestimate. Shipping products early. Not dumbing them down, but making them legible and useful. And once you start shipping, the bottleneck actually moves again. It stops being, how can I build this thing, and can I? And becomes, can I lead? What do we stop doing? What do we double down on? And how do you make a call when your information is incomplete? I asked Richard what he had to unlearn to become a CEO. And we talked about the hardest parts as well. The doubt, the wrong decisions, and the weight of knowing that ultimately the buck stops with you.
I cannot emphasize enough how this is the hardest thing I have ever done. People often say the secret superpower that CEOs have is never being able to anticipate how hard the job is going to be. As a researcher turned into a CEO, you have to transition the way that people see you. I don't think that you ever stop learning, like ever. Your job will never stop changing. You'll always be introducing new functions that aren't related to technology. HR, for example, or finance, or commercial and strategy. You quite often have more things to do than you have ever had before in any career. You live and breathe uncertainty all day long because you're ultimately doing things that no one has ever done before. We needed to be different. So we made a very, very conscious decision to stop doing things that look too similar to other companies, focus a lot more on near-term quantum systems rather than long-term ones, incorporation of these memory technologies, these atomic technologies. These were things that no one has ever really pushed hard, built into their products. And we just decided that we needed to have the confidence to go that was our thing. But that creates endless doubt. You'll always wake up in the morning thinking, or maybe I should do this thing that's just a bit safer. I think doubt is a good thing, and I think it is always right as a startup to, within reason, constantly question what you're doing and how you're doing it. Because I think unless you do question yourself, you never grow, you never adapt the company, you never get better, you never carve out your very defensible, specific way of doing things. Comfort is nice to have, but actually a bit dangerous. ORCA actually went through a period of, unfortunately, letting a few people go. Those people are members of the family, they're great people, and you reach this point where you realize that the people you've hired aren't driving you in the direction that you need to go in. And this is a horrible thing to live through, but almost a necessity. You feel responsible for people, and that's the way you run a company, right? I mean, you are ultimately responsible for the great work, but also the livelihood, the families of the people that you employ. It's even hard talking about it because it's the most sort of gut-wrenchingly, sometimes feels inhumane, but I think ultimately there is a humane reason for it. You're out there trying to build confidence, build market share, build great technologies in the very specific way that you set out as a company. It's sort of driven by this necessity to be competitive in a startup. And the final thing I'll say is that there is no way of doing this job without making the wrong decisions many, many times. And that's something you have to live with. If you didn't make those wrong decisions, you wouldn't make any decisions and you wouldn't do anything. Life goes on and there's no point thinking about what life could have been. You build the constructive path for you going forward, irrespective of what you decided to do in the past. And that is the weird thing about being a startup, is how frequent those things come about, but how quickly you get it and you move on. Those are the moments that make you really realize the job you've signed up to as a startup founder, CEO. You have to stand up in front of loads of people and say, I don't know if anyone's going to agree with you on this, but this is what we believe. This is the way we think that things should be. This is the way that we're pursuing things. There's no one else that's going to be there to make the decision that you need to make. But the amazing thing is you've often got more energy than you've ever had before. 4 times more work than you've ever had before. You've got 8 times the energy, passion to just do cool stuff that no one has ever done before. All the impact that you're having from all the amazing stuff your team members are doing. That's what makes it all worthwhile.
I'm really grateful to Richard for sharing that, because it's a part of the story that people rarely want to talk about, let alone, glamorize. Not the breakthroughs, but the responsibility. When building isn't abstract anymore and every decision you make ripples into real lives. It is an incredible challenge, but as Richard says, it's a space where you can have more impact than ever before, and also an adventure of a lifetime. It also raises an important question, I think, that every serious founder has to have an answer to if they want to last. How do you recharge? How do you pull off, work-life balance or maybe work-life fusion? What keeps you and the mission grounded? So I asked Richard what anchors him outside of ORCA, what he protects, and how he stays connected to why this is all worth it for him.
I do have a young family. My daughter's 7 years old and my son is just turning up to 18 months old. The family is a source of strength for me. Family is the same as company, it's all intertwined in the same thing. There's this weird contrast between the chaos of having children, building up people who you hope will become adults, who do amazing things and build a life for themselves, but also contribute to humanity. At the same time as having like a third child, a company that's sort of trying to do the same thing, building technology, building people. So weirdly, I sort of see those two things as being very different, but very, very related at the same time. I want my kids to grow up in a world where, cool technologies have been used to make the world better. And I guess it stems to my just excitement about what the world will be, could be, should be in the future.
When he talks about his family, it's almost as if you can hear Richard's ambition getting sharper. It stops being, what can we build? And becomes, what kind of future are we building into? And this is where quantum stops being a niche topic and becomes an infrastructure question. Because, the shape of all these huge sectors, from security to scientific discovery, energy, economic advantage, these are all increasingly running through computation. So I asked Richard to transport us into the future. If ORCA succeeds, where does this sit in the real world? And what does it look like when quantum is no longer a novelty, but part of the stack?
Well, I've always dreamed that I will make a technology or something that will be used by as many people as possible. And I get a real buzz by imagining that the things that we are used to using, at some point someone has come up with those things. A mobile phone, a laptop, a camera, a train. Everything we use at some point has come with a point of ingenuity and delivery. And I really look forward to the day that within every data center, within the racks and racks of existing electronics and NVIDIA GPUs, one day you will see an ORCA system. ORCA will power a future where AI, machine learning computers are much better, used for more powerful things such as drug discovery. What excites me is I think right now, partly because of the excitement around quantum, partly because AI has made computing so much harder, so much bigger, the need is stronger for novel computing systems. It seems to me like we're sort of at this moment in time where this dream of making computing different, better, incorporating ORCA technology is now one where we could be there front and center in making a difference to people around the world. That is truly what is the most exciting thing on the planet. It's really so cool.
I love that, because even with the central London offices, the cutting edge tech and the incredible journey, you can still hear the ambitious kid who fell in love with science and what it could do for the world. What I take away from Richard isn't the usual quantum is coming headline. It's this: usefulness is a choice. And the future doesn't just arrive, it shows up when someone is willing to carry the responsibility of making something real. Not just impressive in theory, not just explainable in a lab, but dependable today. And as more of civilization runs through computation, data centers, networks, and models, one of the real leverage points becomes what we build underneath it. Which tools do we trust? Can we rely on this foundation? So here's what I'm left thinking. When old methods stop scaling against humanity's present challenges, how long do we stay in theory, in talk, in research, before someone builds? Who's willing to go first? And if, like Richard, you can combine discipline with vision and just a little bit of daring, can you pull us faster into a brighter future? Something to think about. Until next time.